Really happy to have you here tonight for our very final webinar for 2024 for the NASA Night Sky Network. We're hosting tonight's webinar from the Astronomical Society of the Pacific in San Francisco, California, but I know you all are tuning in from all over. We are thrilled to welcome back our guest speaker, Dr. Robert Nemiroff. But before I introduce him, I want to just do a little bit of housekeeping. Welcome to you. If you're joining us on the live stream, we're super happy to have you with us. These webinars are monthly events for members of the Night Sky Network, though we stream them live on YouTube for anyone to enjoy. If you'd like more information about the NASA Night Sky Network and the Astronomical Society of the Pacific, go ahead. We'll throw some links in the chat now. Thanks to Kat, who's got us from taking care of business on the YouTube streaming and also throwing links in the chat. All right, a couple of quick announcements. I'm really excited. There is an astrophoto challenge happening. It is NASA's Winter Astrophoto Challenge, all about colliding galaxies. You can use your own images that you take or some of NASA's images, like this pinwheel galaxy taken by the Spitzer Space Telescope. I think Robert has a galaxy also in the background, if you know what that is. If you're joining us for the first time on YouTube, feel free to take a look at all of the events that are already posted on the NASA Night Sky Network on the NASA Night Sky Network calendar. And if you're a club who's joining us, if your club has at least 10 upcoming events on the 2025 calendar, keep an eye out. You'll be receiving a set of NASA calendars as well as another special uh, offer that we have that you'll hear more about in January. We're excited to get all of your events shared with the public and also to support you as you're doing those. Kat and Brian and I are going to be taking a break from the solstice on into the new year. We'll be back on January 7th. So thank you all for all you've done this year. We're excited to work with you in the new year. And without further ado, I'm going to go ahead. You're streaming live, aren't you, Kat?
I sure am.
Ready to go? Any other announcements before we get started?
No announcements from me. I just want to wish you all a very happy holiday season from the disembodied head of Cat Roach.
Excellent. And for those of you on Zoom, you can find the chat window and a Q&A window at the bottom edge of the Zoom on your desktop. Feel free to greet each other in the chat window. Make sure to hit everyone, not just panelists. Otherwise, we're the only ones who will hear you. We're happy to say hello too. If you have any technical difficulties, you can also send us an email at nightskyinfo@astrosociety.org. And if you have a question you'd like our guest speaker to answer, please just type it into the Q&A window. That helps us keep track of whether or not we've answered your questions. So without further ado, I'm gonna hit record. Thank you. Welcome to the final 2024 NASA Night Sky Network webinar. This month, we are pleased to welcome back Dr. Robert Nemiroff. Dr. Nemiroff, along with his partner Jerry Bunnell, is at Michigan. Well, the two of them have coordinated and edited NASA's Astronomy Picture of the Day since 1995 at apod.nasa.gov. We all affectionately call it APOD. The APOD archive contains the largest collection of annotated astronomical images on the internet. This has been happening for many decades, and he's the winner of many awards thanks to his APOD and many other things. Dr. Nemiroff is a professor of physics at Michigan Tech. He has worked at NASA's Goddard Space Flight Center in Maryland before going to Michigan Tech. He's got a new book called Faster Than Light that he'll tell you about at the end of tonight's presentation. And he has got numerous awards along the way. I think I mentioned he also is just an innovator in every sense. He was one of the first people to deploy a fisheye camera, night sky monitor that was online. The first one that was up at Kitt Peak in 2000. His current research includes gamma ray bursts and some other interesting possibilities that are piquing his interest. He was once invited to be on William Shatner's Unexplained, but he got cut because he was too skeptical and not sensationalist enough. Although I think you will all agree he is sensational. Without further ado, please welcome Dr. Robert Nemiroff, and we're excited to hear all about the best of 2024's astronomy picture of the day.
Thank you, Vivian. Thank you very much. Okay, so I'm going to now try to share my screen correctly. You might become momentarily disoriented as you're cast about the universe. Um, okay, so I'm hopeful that you're seeing my first slide. If not,
Looks
somebody
great.
please say something. Okay, so in the next hour or so, we'll be reviewing some of the best of this year in terms of astronomy events and astronomy pictures. So this is based on what has appeared on the Astronomy Picture of the Day, which is a website, and it's available on social media. So what we do is we post an image every day, and we give an explanation to try to make things clear, to explain that picture. It was well, so I am Robert Nemiroff, and I'm from Michigan Technological University. Jerry Bennell will not be here tonight, but we invented and keep up APOD. He's University of Maryland. So you can find APOD at apod.nasa.gov currently. So we started this in 1995, and we became one of NASA's most popular websites, and we do about over 1 million page views a day. When we look into the log files, we find typically that every university accesses APOD every day. By volunteers, we're translated into 20 languages and many social media sites. So if you have if you like some particular social media that's not TikTok, then we're probably there. Long story about TikTok. You can ask me later. All right, so some self-promotional slides. What is APOD 2 is that we were given the inaugural outreach prize at the 2022 meeting of the International Astronomical Union. And here we are on the big stage, and that's me and that's Jerry. But as more people will remember, probably, that APOD was featured on Jeopardy! And so here is the clue. NASA's astronomy picture today revealed that this largest moon of Mars may eventually disintegrate. Scary indeed. And so the answer is here, but you can't read that. But it will be revealed during today's dramatic presentation. Okay, so let's go. Let's go to the end of last year. Let's cheat a little bit and go into December 2023. So here is a picture that appeared on APOD. This is not a photograph. This one actually is an artist's illustration. The title that the APOD had is here. You can see any of these, all the ones I will show you, including the videos. You can play ad nauseum until your roommates object. And you can find them at the coded address time date here. So you go to apod.nasa.gov, you look up in the archive 2023 December 5, and you can just keep staring at this for as long as you want until people object. So on the other side, we give who is responsible for creating this. So this actually this event that this APOD shows is depicts with an illustration actually occurred in previous years, but it had to be analyzed, and so the data was and the story was released at the end of 2023. So a particle that was later named Amaterasu hit the Earth's atmosphere and created a shower of lots of less energetic particles that were usually electrons and protons and muons. Those are small particles. So air showers occur actually pretty frequently, but this was the most energetic air shower yet seen. So something that was probably a nucleus of some atom out in the universe hit the Earth's atmosphere with the same force that a baseball pitch at like 100 miles an hour, 140 kilometers an hour would be pitched. And that one thing just hit the Earth's atmosphere and created this great cascade. It was seen by an array of ground detectors in Utah. And there's a lot we don't know about this. So one of the things about astronomy is a frontier where we're constantly learning more. It's not a book where you turn the page and find out the next thing that's true. So we don't know what caused this. We don't know what particle it was. We don't know exactly from where it came from. From where we can see that it came from, there's any number of objects that could have created it. So we don't even know that. So, but we do know that that Earth's atmosphere got hit with these things. So these particle showers are not that unusual. As I said, you've probably been hit by one, but not noticed it. Okay, so let's go to the next one. So this is the SMART lander for investigating the moon by Japan. And it was two things. This was actually in January 2024, the very beginning of this year. So here you see two parts of the lander. This is the one that hops around like a frog, and this is the one over here. You can see my cursor that is a little bit like a transformer that moves back and forth. So this landed on the moon. So it's not just SpaceX and NASA. The moon is opening up in these years to other countries, and as we'll see, even other companies that can go there now and at least put robots on there. So this landed and went to its side because these are not the most expensive missions ever. They're not like the Apollo missions that were very much more expensive. These are done much less expensive. And so this was not designed to go past the lunar night because it needed to be recharged by sunlight. So I think it actually did survive one lunar night to everybody's surprise, but it was a demonstration that small objects can be placed on the moon relatively much more easily than in the past. Okay, so this is another big image that came out. This was featured by us in February. I think it came out in early February this year. So this is an image of a spiral galaxy. In fact, the name of that spiral galaxy is NGC 1566. It's a pretty normal spiral, which is good sometimes to get a normal one because you want to figure out what's happening in normal spirals. So this was taken both by the Hubble Space Telescope, which is on the lower left, and by the James Webb Space Telescope on the upper right. Now, the Hubble image was here before, but because James Webb is relatively new, it was able to pick this up. So what you can do is you can just see how this works. You can see that in the ultraviolet, the galaxy looks a little bit like this, with a little bit of regular visible light in there. But in the infrared, it looks somewhat different. In the ultraviolet, you're seeing massive stars, and dust looks dark. But in the infrared, you're seeing the dust, it glows more. Instead of being dark, the dust glows. And you can see different features here. You can see through some of the dust too. So if I'm going to click this, and you're going to see this exact same image, but it's going to be flipped. I'll prepare you. On the lower side, lower left is going to be James Webb now, and the upper right is going to be Hubble. So 1, 2, 3, switch. Now you might think, oh, I think it reoriented, but it did not. So on APOD, actually, we had a rollover image. So if you rolled your cursor over the image, you could get them to switch, and then you just roll your cursor off and they switch back. So I'm going to hit the P here, and you can see. So what you can do is you can find a star, let's say like this one. And so when you go back and forth, you can see that star is still there. And if you think, well, maybe that was the only one. So now let's try to find this one here. What happens? And this way, you can quench your curiosity as to what glows in the infrared and what glows in the optical and in the ultraviolet. And this is not just cool to look at. This is how astronomers and humanity learns more about star formation. This is a pretty typical spiral, unlike the one that's behind me, which is a atypical spiral. So we're still learning about how spirals evolve and where stars, which are usually in spiral arms, and where they are and where they're not, and how star formation, which is a very complicated process. We're not going to just discover one thing and say, that's it, we solved star formation. We learn little bits as we go, and eventually we understand better where our sun came from, and from that, where our Earth came from. Okay, so I'll go back to this again, and I'll go to the next one. Okay, so we live in a golden age. We live in a golden age because humanity, and NASA in particular, is sending out spacecraft into the solar system. We've got spacecraft at distant planets. We've got spacecraft near inner planets. Of course, we've got a lot of spacecraft going around the Earth and even several around Mars. But this one is a pretty interesting one. It's the Parker Solar Probe. This is currently inside the orbit of Mercury, and it's looping around and getting closer to the sun, and with each loop. But it sees the solar wind. The solar what? The solar wind. The sun emits particles that come off it in what's called a solar wind. And we see the solar wind here on Earth. In fact, parts of the solar wind are when there's an ejection on the sun, the solar wind is one of the things that traces it into the Earth's magnetosphere, and then particles fall to the Earth, and that's what we see as aurora. So we've known of aurora since before recorded history, well, at least as long as recorded history. But the Parker Solar Probe is looking at what happens when you get close to the sun. What happens there? And there's some surprises. We're learning a lot about the sun. We're learning a lot about the solar wind. So I'm going to play this. This is a video that runs about a minute, and it's got music that accompanies it. And so I will actually, how long is it? Yeah, it's about a minute. So you should hear music, and I will click go, and you will see what happens. Okay, so what you see is, okay, I'm going to pause it. Sorry. So these up and down, ooh boy, that wasn't right. Sorry. So these streaks you see, they're particles from the sun that have impacted the Parker Solar Probe in some way to create a streak on the thing. These things in the background are usually stars, but there are things besides stars that you will see. At one point in the video, the edge of a coronal mass ejection that comes off the sun actually passes the Parker Solar Probe, and you can see it. You can see it with your eyes in the video, which is a time lapse over like a couple weeks. And you can also hear it in the music because we lined it up so the music changes its tone right at the coronal mass ejection. So we will go with that. You're looking sideways from the, here's Mars. You can't look right at the sun. It's too bright. There we go. Coronal mass ejection, just a weak one, just went right past. There goes Venus. There's the plane of the Milky Way galaxy there. Earth, just another planet. This is Beethoven's Symphony Number 7. You got one more planet in the planetary disk over here. There's Jupiter. Okay. So, yeah, so the solar wind is different near the sun inside the orbit of Mercury, and it keeps getting closer. This year, 2020, well, next year, 2025, it will keep getting closer yet. It will be its closest ever during the next coming year. All right, so all right, so again, the moon is being invaded by Earth probes. And this is, again, not from NASA. This is Odysseus. And this is from a company, the Intuitive Machines. And Intuitive Machines landed something near the lunar South Pole this year. And so this was the first landing by a US entity since Apollo 17. So the US is back on the moon already, and it was with Intuitive Machines. Now, this was launched by a SpaceX rocket, that's true, but Intuitive Machines itself is not SpaceX. So it landed near the South Pole of the moon because it's hoped that there are shadowed craters near the South Pole that have little flecks of frozen water ice in there that might be useful for humans when humans return to the moon. And NASA is, and companies and other nations are planning that to go back to the moon. But this landed near the, this image itself is before landing. So you can see the landing gear out on the right here. But then it landed a little short time after this, and it again was not designed to survive the lunar night. So on the moon, the lunar night lasts, for half a month. So it's tough being without the sun for that long. Now, we have had probes survive that long, but these are relatively inexpensive probes, and so they are not yet designed to do that. But it's great that there's this new push to go to the moon, not only from NASA, but from companies and from other countries. Okay. So this is a kind of a really cool image that was submitted to APOD. This is a Pinnacles Peak in California. So this is the Seagull Nebula, and it's called the Seagull Nebula, drum roll please, because it looks like a seagull. Who would have ever guessed? So we found that when nebula. This is an emission nebula. So what you're seeing mostly is hydrogen gas that's excited by stars and collisions, and then drops down from the hydrogen from an excited state to not excited state and emits different colors, but the red colors are picked up mostly by visual cameras. And so that's why it appears red here. So we live in another golden age. Not only are we going out throughout the solar system, but the cost of amateur astronomers that can pick up faint nebula like this is dropped, and so there's many more people doing this. So one question is, well, can't you just get these big telescopes? Can't James Webb do a much better image of the Seagull Nebula than was submitted here? And the answer is, well, not really, because the James Webb Space Telescope sees like a tiny little bit of the sky, and Hubble sees a little bit more. And so in order to get this wide and this deep an image, amateurs just can take their telescopes and their digital imaging equipment and their digital processing afterwards and create great images like this, and sometimes discover new things. So a lot of people in the Night Sky Network who are the main audience here, you've done this yourselves, or your astronomy club has done this, or you can go to an event and a star party at night and see images like this. Although this is processed, you would see a much more faint image in real time. So let's see, what do we have next? Ooh, so this was submitted to us, and we didn't, we didn't ask for it, but when it was submitted, it's like, wow, this is really cool. And this could have been done by almost anybody. This is in Italy, but it's looking opposite the sun, not at the sun. So as you know, during the day it's bright, and during the night it's dark. God, I hope you know that. But anyway, as you look up in the sky during the day, it's relatively bright, but eventually it becomes dark. But how does that happen? It happens in this, every 10 minutes or so, there was another picture that was taken, and they were put together in bands by digital processing. And so then the foreground is taken, this foreground is taken. So the usual one during the day, at the night, you can see it's bright here, but then you see as darkness descends, you get something called the belt of Venus. So if you look opposite the sun as the sun is setting, and there is sort of a red sunset behind you, then you will see a red band of the sky that sort of goes around the sky, and that is called the belt of Venus. It's something that like everybody has seen, but many people haven't thought to point out, this belt goes pretty far around. It's called the belt of Venus, I guess, because if you keep going around, you have to go back near the sun. Venus would frequently appear in this belt. The next thing that you see is more of the shadow of the Earth instead of the shadow of the sunset, or the image, the double reflection of the sunset. So during blue hour, it's light in the air, but it's not light on the ground. And so it can be longer or shorter than an hour, but you get a blue band of the sky, as you can see here. And a lot of astrophotography is taken during the blue hour because you have enough light to image the foreground, but it's not too much light, so the foreground is washed out. And then what you do, as with the Seagull Nebula, is you then wait a little bit, because only an hour or so later, the background is dark enough to take really deep images of the background, and then you digitally superimpose those. So why at APOD would we be interested in those images? Because they're actually somewhat similar to what a human would see if they were standing there. So sometimes we take, conglomerations. We don't want complete fabrications where you take the image of one thing and take another image of something else completely and just slap them together and say, there you go. That's just not realistic. But when you're recreating what would be seen, we're more likely to run it. Also, things like meteor showers, when there's lots of different meteors, you have to take different pictures of the meteors to put them all together into one image. So there are several times when we will be, interested in image conglomerations, particularly when they're very educational. Then on the far right, there's something called the red band, which is even below the blue band, which I guess has something to do with the, I don't recall seeing this, or the 2-degree Earth. The horizon band I can see, because that's just right above the horizon. But it's interesting that even sunsets, something as obvious and everyone has seen as a sunset, can actually be broken down into all these different epochs. And some of them are harder to see than others, but they were really put together well in this image. So when we saw this, we said, oh yeah, we're running this. And we got to describe it in the little paragraph below. Okay, so there was an image, there was a comet that just about reached naked eye visibility. Not the comet you're thinking of. This one was the one earlier in the year that some people have forgotten about. It was Comet Pons-Brooks. And here you can see the comet has many classic features that did not occur with the other comet, which we'll hear about later. So this comet sort of has a green coma. The coma is the gaseous bubble around the nucleus, which is the dense, dirty, icebergy ice chunk that's the nucleus. So there you can see it's glowing in green, but now you see a really interestingly detailed ion tail of Comet Pons-Brooks. Now, if you went outside with your eye, you would just barely be able to see this. But with cameras, you can just open the camera and have the camera integrate for sometimes only like seconds, a few seconds, and you start picking out these really clear details. What creates these details is actually this two things. One is the solar wind, which is very complex. It's not just a simple wind. Usually it has different features to it. And plus, the comet nucleus is probably rotating. So as jets come out of the comet, as it warms, as it gets near the sun, you can see different streams coming off the comet. So these two, I'm sorry, I keep moving the cursor. You can see these things, and comets create works of art many times as they get near the sun. So one of the cool things about Comet Pons-Brooks is that people thought it would be visible the next month with the unaided eye during a special event that many people might have seen. So we will go to that event. Before that, this is part of the drum roll. In this past year, more was known about the central black holes of some galaxies, including the 4 million solar mass black hole in the center of our own galaxy. So this image, which was taken by the Event Horizon Telescope collaboration, was taken by many radio telescopes all over the Earth and then digitally created later. But what was done this year was that the polarization of the image was determined and then put on here artificially to show you where the lines of constant polarization are and the direction of the constant polarization. So there's gas between us and the central black hole, which is why the image is never totally dark, because that gas can glow. And so this image has been augmented now by how we know the magnetic field, which creates the polarization of the gas around and the hot spots around the black hole. Now, this image, even before the polarization, became a little bit controversial because you can take the data from all these telescopes and you can combine them as the Event Horizon Telescope collaboration did. Or it turns out there's a competing group that says, well, you know what? We combined all that data and we got something a little bit different. So even what the central black hole looks like is still a little bit controversial, and that controversy will surely carry into 2025. These lines of magnetic field lines actually tend to bolster the Event Horizon Telescope's collaboration's original picture of the central black hole. But it's something we're learning about. And with imaging the central black hole, we learn about the accretion disks of gas that are really hot, that surround the central black hole, surround other black holes, the magnetic fields there, and even a little bit about the gravity that's there too. Okay, so who here, so I can't see you, but raise your hand if you saw the total solar eclipse that occurred in April 2024. Oh, I really can't see you. So this image here is another conglomerate image that shows you what happened. So here you see the diamond ring of the moon mostly covering the sun, and you see a really interesting prominence. And then soon the moon moved to totally cover the sun. So about an hour after first contact, well, it depends where you are. If you're near the center of the line of totality, about an hour, then the moon completely covers the sun. So why would the angular size of the moon be almost exactly the angular size of the sun, so it blocks it completely? And the answer is, we don't know. It's this really strange coincidence. Sometimes the moon is too far away in its elliptical orbit and it doesn't block the total sun, and then you get an annular solar eclipse at most. Most of the United States and much of North America saw at least a partial eclipse where the moon wasn't exactly aligned and so only eclipsed part of the sun. But those are still pretty cool to see. So Again, this was one of two eclipses. One was in 2017, and this one was in 2024. I was fortunate enough to see both of them. And people from my university, we had all this planning. We were poring over maps. It turns out that totality just clipped Michigan, my home state, just a tiny little bit. And so originally I wanted to go to that tiny little spot that would see like just a few seconds of totality, but I was talked out of it by my students because they said, well, look, if it's cloudy during those few seconds, you're out of luck. And also, we want to see a total eclipse that goes longer. So what we did is we drove into Illinois, and which is near the path of totality, and then we had a stay over the night before, and we poured over weather predictions, we poured over maps, and eventually we went to Southern Illinois, and we went to the parking lot of a Walmart. And we camped out there, and we were able to see the complete total solar eclipse, which was amazing. So one of the things about total solar eclipses is that you get to see these prominences here. So these prominences, you look like they're a bad Photoshop job where somebody decided to use too much pink. But I'm here to tell you that prominences are really shocking pink. They're not orange. And a lot of the pictures you see, they're just like orange, like the rest of the sun. The sun actually appears mostly white. It's hard to see any orange in the sun. If you had to attribute color to the sun, it would be more toward the green. But it's just this people just have been coloring it orange for a while, so people just keep following that. But the prominences, which you can see with your eye during a total solar eclipse, are shocking pink, and they are really cool. So if you get another chance to see, which actually won't be a while in the US, but you can travel around the world. An eclipse happens every year or so, a total eclipse, and you can see the amazing prominences around the sun. So the next we have another video of this is a total solar eclipse from Sliver to Ring, it's called. So this was sent in to us again by Reinhold Wittich. And so another familiar tune, this is from Strauss. So I'm just going to play this, and you're going to see after a few seconds how long this one runs. This runs this runs a minute and 25 seconds. So you're ready. So it doesn't all happen right away. I'm going to play this. You'll hear the music, and then you will see the moon move in front of the sun. Ready, set, go in time lapse. This is from Mountain View, Arkansas, not Mountain View, California. There you see the moon begin. The sun is very active, has lots of sunspots, and you can see sunspots here. You had to play your own music to kind of hear the music. The total eclipse doesn't come with its own music, sadly. Here you see the diamond ring effect, also sometimes called belly beads when there's more than one. Looks like a bright diamond ring. And now, I'm going to pause it again. So now there's image processing has gone on here. You really can't see the corona go this far out. You do see the corona right around the sun, right around the moon in front of the sun. But here with the miracle of modern digital processing, you can trace the corona really far out and see essentially how the solar wind is emitting from the sun. And what is actually color correct is the prominences, which are pink. So there's usually only a few minutes of totality. The moon is in front of the sun. Not see a lot of change in the flow, but now, after a few minutes, the moon will move out of the sun, the prominence, and the sky becomes much farther down. It's so bright, you can't see the corner. Not that it's appeared, you can't see it. Okay, so let's go on from there. So something somewhat unexpected happened the next month, in that there was a huge sunspot group crossing the sun. Now, many people had solar eclipse glasses, and so you could take your solar eclipse glasses and you could go outside in May and put on your solar eclipse glasses, and you could see without any magnification this great giant sunspot group. So don't throw away your glasses because there could be other great big groups crossing too. And I apologize for, okay, so here's a blow up of it, and this was submitted to us. And little did we know that this sunspot group would be more than just a visual sight. This sunspot group had a lot of flaring activity and coronal mass ejections that went out into the solar system and impacted the Earth. And when that happened in May, there was a tremendous amount of aurora that was visible pretty much all through the United States. So please raise your hand again if you saw the aurora in May, which was an unexpected northern, well, USA event. And it was even seen in parts of Mexico. So even if you live in California, if you knew when to go out, you could see this if it was clear enough. All right, so we were sent a lot of images of this. We didn't really realize what was going on until the images started pouring in, and then we said something's really happened here. And so we got to run the best of them. So here's one from the Karkonosze Mountains in Poland. And here you can see the lower aurora are green and the upper aurora are red, and this case a little bit purple, and you can see the rays of the aurora come down. So this happens to be one of the cool images because you can see the city below and you can see an observing station that was already there. It looks kind of futuristic. And so this is one of our more popular images that was sent in. So in APOD, we sometimes when we get a bunch of good images, we run them on what we call on a Facebook site and try to judge popularity based on it. Popularity is not the only way we run images, but it is one consideration. If something is really popular, then we want to get out ahead of this and say, here's, okay, you saw this image, here's what's really going on there. But this one was really popular, and all right. So again, there's many images on APOD that were of this aurora, and many people saw it. Okay, in 2024, thanks to the James Webb Space Telescope, a new farthest object was found. So in the inset here, you can see a blob, and it's just a blob even to James Webb Space JWST. And the red part of this blob was, they determined a redshift. The higher the number in the redshift, the further it is. So this object had a redshift of, drumroll please, 14. Z was 14. And that means the universe was 1/50th, 1/50 of its present age when light left this galaxy. And one of the things about James Webb is that it allows us to see further into the universe, and we can see these very early galaxies, and we can try to figure out what's going on when galaxies formed. And so when galaxies formed, soon our own galaxy formed, and from that our own sun formed, and during that time or soon after our Earth formed. So these don't usually have fantastic names. This PJ's GS Z14 coded into the name as its redshift, and it is currently the furthest object known. But James Webb's running great, so I might not hold this distinction for all that long. Okay, so this is a video, another time-lapse aurora over a couple hours. So here you see, this one was taken from China because you could see this all in much of the Earth. If you're right near the equator, then you couldn't see it. But if you're a little bit away from the equator, you could see during this this May event. And so this is a video of how it changes. So here you see the red aurora, or looks kind of purple here, but this is something called a SAR arc, a stable red arc, that it's been seen for a while, but they're only being studied in recent years. And this is related to particles the aurora is related to particles that are being channeled into the Earth's atmosphere by the Earth's magnetic field. This is probably more related to streams of particles moving in the Earth's atmosphere because there's been all this activity in the Earth's atmosphere because of the aurora. The atmosphere needs to readjust. And when that happens, you get a stable red arc. So let's watch. This is a 360 image, so it goes all the way around. You're seeing all the way around, even behind you, and you're seeing all the way up to the top. So weird things happen to the top because of the projection effect. So let's run this. You see satellites and even some airplanes zipping around. And you can see the aurora change shape. And you can see the stability of the SAR arc. You can see cars over here. driving with their headlights, and you can see a band of the Milky Way galaxy right here. So it was when aurora are this bright as they were in May, even people who study aurora begin to notice some new things. And so it was an event that was visible to much of humanity, but it was also an event of interest to professional aurora chasers, professional scientists who study the Earth's magnetosphere, the sun's ejections, and how it interactions in the Earth's atmosphere, how it restabilizes. So new science is being learned even this year. Okay. Another big thing is exoplanets. So the exoplanet zoo passed 5,500 known objects, and we don't really know what they look like. These are all artists' renderings. So in the middle, you see a lot of blue planets that were guessed to be blue. Well, the color we might sometimes get, but they're a little bit like Neptune. So the middle has like the Neptune. Obviously, we didn't get all these to pose for pictures. This is a artist rendering of the exoplanet zoo when it had lots of, as it has now, we only keep adding to it. Some of the Neptunes have rings like our Neptune does. On the Jupiter-sized objects are on the left and the right, and the person who created the digital images threw in a little joke because this is actually Jupiter down here. But all the small ones are things, there are rocky type planets that we know a lot of rocky type planets now. Some are similar in size and mass to the Earth. So as we analyze image data from Kepler and TESS, and as we look deeper with James Webb Space Telescope and sometimes Hubble Space Telescope, we're learning more about the many different kinds of moons and planets that are orbiting stars other than our sun. Okay, so this was taken by Mars Express. I'm sorry, I'm going to take a second here. My voice was. So this was a picture taken from Mars Express, which is a European mission, ESA, as it says here, but NASA did contribute to the mission. So here you see just a really cool vista of Mars. So here you see the largest volcano in the solar system, Olympus Mons. And here you see another one over here. And that's really cool because you see it on the horizon. You can see the shape of the volcano. Here you can see some circular craters, which are not conceptually different than the craters on the moon. Here you can see Phobos, which is the answer to a previous Jeopardy question. And it's actually a really dark moon. Our own moon is pretty dark. It's just that it reflects, it's so much lit by the sun and is so much brighter than the very dark sky behind it that it appears bright. Oops. So let's go previous. And so you would think that we know everything about Mars, but because of missions, particularly the landers, the rovers that NASA has landed on the surface of Mars, we know Mars had a wet history. And we know that life could have existed on ancient Mars, but we don't have direct evidence that there was life on early Mars. There's lots of stuff about Mars we still don't know. For instance, Orcus Patera is this unusually shaped oblong feature down here, and we don't really know what caused that either. So there's still little mysteries. The more you look at something, you begin to understand some things, but then there's other things saying, I don't really understand that. And so astronomy and space science is continually like that. NASA is frequently discovering the answers to things that we wondered about, but also uncovering things that, what's that about, that we try to answer as well. And sometimes it's an answer, maybe sometimes never, sometimes at the next mission. Sometimes missions are designed to try to answer some of these questions. Okay, let's go to the next one. So this again was done by an amateur astronomer, but it was based on NASA data from the Lunar Orbiter Laser Altimeter, which basically bounced lasers off the moon and told us how high everything is on the moon. And if you just have a list of numbers, at this position on the moon, the altitude is this, kind of boring. But an amateur put this together and say, okay, I'm going to exaggerate it. So this is what the moon looks like if we exaggerated the height by like a factor of 10 or 100. And here you can see why this is called the lunar highlands. So the moon doesn't really look like this. Also, the colors are exaggerated to show different elements that are more abundant in some places than other. Iron and aluminum are shown. But here you can see The different maria are actually low parts. It's just very clear from looking at this. And the different highlands with lots of craters and especially near the edges, you can see that the moon has actually got a lot of different terrain on there. And so again, this was submitted to us and we said, this is just really cool. This isn't the way it would appear to a human because the moon doesn't, these features are exaggerated. The moon does look really cool, but it looks different. But this is an educational image and a really cool way to visualize certain aspects of the moon. Okay, so here's the drum roll comet that many who saw this comet. So this comet is pronounced Tsu, 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 everybody now. Chin, Shan, everybody. Tsu, Chin, Shan. Good. I couldn't hear that, but I'm happy that you tried or might have tried. So this person here is Abraham Lincoln. He kind of died a while ago, but over his right shoulder is this thing up here. This is Comet Tsuchinchan. And it was visible to the unaided eye. It was a really cool comet that was visible in mostly October a couple months ago and was quite an event. And so let's see. So here it is. The comet was so bright that you could take it behind almost anything. And sure enough, we got pictures of the comet behind almost anything. But this is one we really liked a lot because this is a picture of the comet behind the Europa Clipper, which has blasted off and is headed for Europa, which is a moon of Jupiter, which might have underground oceans, which might have some sort of life in there. It might have little microbes. And it won't land on the surface, but it will make many passes by and take pictures that will tell us a lot more about Europa. As you might know, well, Freeman Dyson, a famous scientist who died recently, speculated that there could be frozen fish orbiting Jupiter as rocks, big rocks might have hit Europa and blasted off some of these things into the interstellar space. There's no easy way to find interstellar fish or interplanetary fish. But what we can find is we might be able to find more common microbes or indications that there are microbes. So this is an exciting NASA mission that will play out over the next several years. Okay, so this is a really cool video that was sent to us before the closest approach of Comet Tsuchinshan Atlas as it went in. So this is the sun over here on the left, and this is the comet. This is not real pictures. This was created as a prediction for what the tails would look like, and it turned out to be pretty accurate. So there's no sound with this video. It's a pretty short video. It is 25 seconds. I will run this. Okay, so here you see the tail is getting longer and longer. Boop, 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 boop. And now it's going to move slightly in front of the sun and slightly above the sun. Sound effects are free by me. And now you can see the dust tail has two parts to it. It has a dust tail of thin dust that points away from the sun and a dust tail called an anti-tail that points toward the sun of more larger dust grains there. And so sure enough, when you take pictures of it, and this is again the comet over California, you can see the part of the thin dust tail here, and in the ion tail that we saw with the other comet is actually mixed in here. It's hard to see. And this is reflected sunlight here. And this is also reflected sunlight here. This is a globular cluster and not a planet, far in the background. But this is the anti-tail, which is one of the really cool things about this comet. It had a very strong anti-tail, the strongest I've ever seen. And this was visible to the unaided eye. Hopefully, so I was able to go out with some friends and students and see it a couple times here. Okay, this is another one of these great images that was taken both by the James Webb Space Telescope and by the Hubble Space Telescope. I'm running a little short on time, so I don't know if I'm going to go into this in much detail. I will flash these a couple times. This is in the Small Magellanic Clouds, which is a small satellite galaxy to the Milky Way galaxy. This is a star cluster there. The star cluster's number is 602. And so I'm going to click and you can see what happens if you go from the infrared, which was taken by James Webb Space Telescope, to Hubble, which is more toward the ultraviolet. And I'll go back and forth, pink. And the stars do line up, and you see slightly different things. And it's these differences that are one of the things that are making these two telescopes working in cooperation so interesting, that we can learn so much. Okay, so this is another image of comet to Jinshan Atlas, and here you can see the famous anti-tail. But I ran this one because there's this dark streak that goes there. And it occurred to us in APOD Central that there's a lot of these dark streaks. So a lot of these images, particularly taken around the mid-October, October 15 and 14, were showing this dark streak. So we started wondering, what is this dark streak? And so we contacted some real people who are quite expert in comet tails, and they didn't have a consensus, to our surprise. So then we called for people to submit all their images that have this dark streak in there. And you can see other images that have certainly different parts of the tail. But what this might be is this is the plane of the comet, and the plane of the comet runs in a certain way. And so this dust here is actually more faint than this dust there. And so the plane actually might create the dark streak itself, but we're not sure. I think this will be solved relatively soon because there's so many pictures of the comet, but it shows again that some bright things that happen, professional astronomers, we don't completely know what's going on with it, and we can learn from it. Sometimes we never find out, and we have to wait for other comets or more modeling to find out. Computer modeling. Oh, this is a really great one. This one was sent, this is in December of this year, December 4, it was sent in. So a lot of people create analemmas. So so this analemmas are based on the question, does the sun return to the same spot in the sky every day at the same time? So is it always straight up at noon? No, it's not always straight up at noon. Is it always over here at noon? And the answer is no, it moves around, and it actually makes a little figure eight. So a lot of amateur astronomers in particular would build up these analemmas. But this guy, Nick Wright, came up with this really interesting idea where he had this shadow in his driveway that is a corner. And so he tracked where this corner is on a webcam. And he created this video. And you can see the analemma of the sun, which is the opposite of the direction of the sun at noon, makes a figure eight over the year. And when it was pointed out to us, we couldn't wait the whole year for it to happen, so we ran it before then. But so we'll probably rerun this when the thing is complete. But one of the things we like about this is really easy technology. You can just take your webcam and take pictures of where the corner is of a shadow of your house on your driveway, and figure out interesting things about the sun, which is related to the tilt of the Earth, and track the sun in the sky really simply without having to go out every day and find out where the sun is and being worried the sun is too bright. So this is a sort of a mental jump that because modern technology makes this easier to do. Okay, so, and then the latest meteor shower was the Geminid meteor shower, and it wasn't that great because the moon was pretty bright, but even so, we have submitted images, and here you can see some famous sky objects, the belt of Orion, which you can't see so easily here, the constellation of Gemini, which is where the meteors appear to come out, the planet Mars, but it wasn't that spectacular because the moon was so bright. So there'll be a less good meteor shower in terms of number of meteors in January, but the moon will not be so obnoxious as to create such a bright sky. So we're frequently asked what is the most popular image. So one of the most popular images in recent years, which we ran this year, was just an image taken by an amateur photographer, who from Guatemala, I think it is, found that the moon in crescent phase had a cloud that went right across it, and it looked a little bit like Saturn. So yeah, that is kind of cool. So we ran it, and it was wildly popular. And so we rerun it. We rerun some of the best images. And again, it's really popular. So sometimes you just see this, you're in the right place at the right time. You take out your camera phone and you clip it and say, there you go, caught something. And it's just really cool and inspires people. So this is an image like that. So I just want to say as a postscript that if you don't know already, please check out the Night Sky Network, which is hosting this event, and it's at nightsky.jpl.nasa.gov. And it's Astronomy Cause bringing the wonders of the universe to the public. So I want to say that APOD celebrated its 29th anniversary in June 2024. And last, I have a book. It's called Fast and Light, How Your Shadow Can Do It, But You Can't. It's written on a popular level. It's meant to be both fun and funny, and you can get a free digital copy if you're a Night Sky Network member by seeing the Zoom chat. And with that, I will conclude and open up for questions for whatever time we have left. And I want to thank the Night Sky Network for inviting me on, and for NASA for running this on their page. And I always enjoy speaking to the Night Sky Network and to many groups. So I hope you enjoyed tonight's presentation, and I will stop my sharing at this point. And there we go.
Robert, thank you so much. That's awesome. I love having you on. I feel like we get such a good review of everything that's happening here. I'm gonna
Thank you.
pin you, maybe not. Nope. Maybe I'll pin myself and we can oh, unpin. Hi. We've got some great questions in the chat, and there we go. Removing all the pins. Oh,
Okay.
so Jim Hendrickson mentions that APOD is a Saturn year old, or as my mother would say, it's Saturn returns. Yeah. So
Well,
congratulations. Happy 1 year anniversary on Saturn. I love that Saturn and the moon picture. There was another question that someone asked early on. Let's see. Ron Schmidt said, now that we have all this great astrophotography equipment, what percentage of your APODs are taken by amateur versus professional? Do you do any breakdowns on that?
I don't have exact numbers, but I can guess. So I would say it's about, maybe it's divided into thirds, about a third roughly NASA images that originated at NASA or a NASA supported thing, a third by professional photographers, and a third by amateurs who just happen to be in the right place at the right time.
So cool. That is great. And there's a question about your background image. We were having this discussion right when we got started. What is that behind you?
So this is the problem. This is a colliding galaxy. It's ARP something. You can find it on APOD. I won't remember the exact phone number for it. So it is two. You can see there's the blue thing. I really like it because it sort of puts like a halo sort of around me. Not that I deserve a halo, but it's kind of a cool effect. It's like I'm sitting in a galaxy chair, and the center is part of a different galaxy that recently collided with it. And so some of the coolest images of galaxies are of them colliding because they create stars as they collide. As the gas parts collide, they condense into stars and they create like rings and other parts of and filaments of star formation. So I have a cat here that's meowing. I don't know if you can hear her, but she is cool.
That's great. Very cool. Let's see. So there is questions about the dark strip in the tail of the comet Suchin-Chan. Is that right? Did I say that? Yeah,
Good.
right. That indicate that there's a split and maybe two tails. Is that possibly what's going on, or at the time, do you have any idea? That came
Well,
from
there's certainly the anti-tail that goes in one direction and the other tail that goes the other. Whether there's a split or not, we only see it from one point of view. We don't actually have depth information generally. But many times, though, it is possible for there to be different parts of the tails that go on. That might be because the comet might be rotating, or it might have had an event where it emitted a lot of dust. This was Tsuchinchan was a very dusty comet. And so it might have had events where it expelled more dust than others. And then it was relatively quiet, and then it expelled even more dust. And so you could have episodes of slightly different tails that are then pushed out by the solar radiation and the solar wind. But in general, though, I think it's essentially one tail for this comet, from what we know.
I mean, between the comet and the Northern Lights and the solar eclipse, I feel like we just lucked out in a big way in astronomy this year. The naked eye.
It was a great year.
Yeah,
Yeah,
yeah, it totally was.
it was great for going out and seeing astronomy with just your unaided eye. Yeah.
Right, or solar eclipse glasses,
Yeah,
solar
the
viewing.
solar eclipse glasses, right.
I think we have time for just one more question, and it has to do with post-processing. Ron's asking about some pictures. With post-processing, some images have become more painting than picture. Some people have a huge problem with turning it up to 11. Where do you land on that debate? Do you let them
Yeah, so that's a very modern debate. So there's no clear answer to that. So we debate this amongst ourselves all the time. And many times if it's turned up to 11, it just looks fake, and it doesn't. If it does, if it turned up to 11, we're very much less likely to run it, except if there's some scientific reason. If you were exposing in O3 in oxygen, for instance, and you turn that up because you can see the oxygen in something is actually really interesting where it is, then we can say, well, that oxygen was turned up to 11. You wouldn't see that, but it's educationally interesting. And so there are times when we will show that. Many times, what so many people do is they slightly brighten some of the stars in some situations. So at some point, they're not turned up to 11. You might say they're turned up to 5. And so we do have a tolerance for that. So yeah, you can turn it up to 5. So many times the Big Dipper is not as obvious as it appears on some of our images, and we're sort of painfully aware of that. So if you go out and look for the Big Dipper, as many people know, it's called many different things in many different cultures, then you sort of have to know where to look. It doesn't just jump out at you from the sky. But once you know where to look, you can say, oh yeah, there it is. But sometimes in the pictures, it's a little more prominent than it should be.
Yeah, yeah. Robert, I want to thank you so much for joining us tonight. It is such a pleasure having you on, and thank you for everyone for tuning in as well.
Thank you so much for inviting me. I enjoy this.
Great. You can find a recording of this webinar along with many others on the Night Sky Network YouTube page, where some of you are joining us from tonight. Each webinar's page also features additional resources and activities, so there's plenty to look at there. Please tune in and join us for our next webinar. It's coming up on Tuesday, January 28th of next year, 2025, 6 p.m. Pacific Time, 9 p.m. Eastern. We'll have Dr. Michael Seifert join us, and he's going to discuss the Euclid Space Telescope and the search for dark energy and dark matter. Thank you all so much. Have a wonderful solstice this weekend, and we'll see you in 2025. Take care. Keep looking up. All right.
Okay, so that was cool. Thanks
So much,
again.
Robert.
Really sincere about
Such a
my
pleasure. Have
So
a great break.
yes, so everybody have a great break. I